In this video, we deploy Windows Virtual Desktop Session Host with an Azure DevOps pipeline. Hello everyone, I'm Travis and this is Sraltos. This is part 4 of a multi-part series outlining my experience with Azure DevOps. In the last video, we used a DevOps pipeline and ARM template to deploy a new image with Azure Image Builder and add it to the shared image gallery. In this video, we're going to use another DevOps pipeline and ARM templates to build new Windows Virtual Desktop Session hosts from that updated image. The steps could also be applied to other Azure virtual machines as well. Before we get started, please like, subscribe, share, and click the bell icon for notifications of new content. Your support for this channel is greatly appreciated. If you'd like to learn more about Windows Virtual Desktop, check out my course, Zero to Hero with Windows Virtual Desktop on Udemy.com. Let's get started, and I'm not going to lie to you, this is going to be a long one. But if you stick with it, I think you'll find this pipeline helpful for deploying new session hosts or other Azure VMs. Now you can use this however you'd like, but here's what I have in mind. If you build a new host pool with session hosts based on the latest image, how do you update the session host when the image is updated? This is a real issue a lot of environments are facing. At this time, Intune doesn't support Windows 10 Multi-User, and Azure Automation Updates doesn't support a client OS like Windows 10 Multi-User. That leaves Endpoint Configuration Manager. But session host and a pooled host pool should be treated like cattle, not pets. Instead of applying patches, this solution builds new session hosts with the updated image to replace the previous version. This could just as easily be used with software or other image updates. It would be tedious to manually deploy new session hosts every time they needed to be updated. That's why we're using a deployment pipeline for this solution. To make this work, I needed an ARM template that adds session hosts and also adds them to the Log Analytics workspace. I started with a template available from Microsoft's GitHub Repo. This was close to what I needed, but I had to make a couple of modifications. I removed everything other than what's needed to create an availability set and then build the session host. I then added a resource that installs and configures the Log Analytics agent on the session host. This way, data is collected for monitoring insight as part of the deployment. An understanding of ARM templates will be helpful, but I go over each setting to get it to work in the demo coming up. I'll leave a link to a blog post I did a while ago that goes over ARM template basics. Let's discuss ARM parameters because I did end up with a sort of parameter inception with this. In an ARM template, a parameter can be changed to fit a deployment. For example, a VM disk type or the use of availability sets can be specified as a parameter. Some parameters are changed more frequently than others. For example, the VM name prefix or the VM size. We can create a parameter file that overrides the parameters in the ARM template. This makes the template portable. You can use one template with different parameter files. If you had multiple host pools, for example, you could use the same ARM template with multiple parameter files for each host pool. It goes one step further with DevOps pipelines. We can specify override parameters during the resource manager deployment. We'll use these for security items like admin and domain join passwords. Here's another way to look at it. We can set parameters in the template file, then get more specific for the deployment with a parameter file, and then use override parameters in the DevOps pipeline. Any of the template parameters can be overridden by the parameter file. If they're not in the parameter file, the default value is used. If you'd like to follow along, create a new Azure DevOps project with the files at the link below and open it with VS Code. The steps to do that were outlined in a previous video. We'll create a new pipeline that adds session hosts to an existing host pool, so you'll need a pooled host pool to follow along. Don't forget to shut down or remove the VMs when finished to prevent charges. Let's go to VS Code to get started. Here we are in VS Code. I'm not going to go over creating a project and opening it with VS Code again in this video. If you want to see the process, check out my videos on how to do it. I'll include a link above. I have a couple files, an ARM template and a template parameter file. The template is the instructions for building the resource, session hosts for this example. These files are available at the link below. It's not lost on me that I put Azure DevOps files in a GitHub repo. It was just easier for me this way. The template has multiple sections, parameters, variables, resources, and outputs. I'll include a link below to a blog post I did that goes over ARM templates. At a high level, parameters are items that we can change for each deployment, such as the VNet settings or the OU the session hosts are deployed to. You'll recognize the parameters from deploying session hosts through the portal. It's just a different format of the same information. This solution uses a linked template to actually deploy the session host. The link points to a public Git repo hosted by Microsoft. You can copy these to your own repo and update the nested template location parameter if you want to use your own copy as the source. Do this if you're concerned that modifications to the linked template may change and break the deployment. Or maybe you just have a requirement not to use a public template. Notice that some of these parameters have default values and others don't, or the default value is blank. Tags and host pool names, for example. Now, if we go down to availability options, the default value is availability sets. It also shows that the other options are availability zones and none. If we change nothing, this will deploy an availability set. I suggest keeping it as availability sets for Windows Virtual Desktop. Also, if we scroll down to resource groups, notice that the VM resource group and location uses a function to reference the value from the deployment resource group. So when we deploy this template, it requires a resource group, and that's the information it's going to pull in and use. Configured this way, we'll always deploy new session host to the same resource group as the existing session host. Let's go down to VM image type. Here it uses a custom image. That's what's needed to build a VM off from the latest image definition in a shared image gallery. Let's go on and look at the variables. Variables are internal to the template. The first line builds the availability set name by adding avset hyphen before the VM prefix. This way, we'll know the availability set that goes with the VMs in the deployment. After that, we have resources. First, it builds the availability set. After that, it uses a linked template, in this case, a template hosted by Microsoft, to build the session hosts. It references the template and passes along all the required parameters. After that, I added a resource to add the log analytics agent to the new session hosts. This is so we collect data for monitoring insights. We have a lot of parameters and not all of them have default values. As mentioned previously, we can include a parameter file when deploying the template that provides values for those left blank or overrides the default values. Let's take a look at that. This is a little shorter. You can change any of the parameters to modify the deployment for your environment. What I tried to do here is include only those parameters that you'll need to modify for your environment to make it more manageable. For example, take a look at the tags value. You can modify them for your environment. We have a host pool name and a link to a key vault. Both you'll need to change for your environment. It goes on with credentials for the VM and the VM size and the number of session hosts. Here's the custom image source ID. This is the ID of the shared image gallery definition we'll use as the base image. After that, there's some VNet settings required for your environment, an OU path, and domain. The last details are for the log analytics workspace. I'll point out that there's multiple references to the Key Vault secrets. That was covered in the simple server build video. The secrets we need are the domain join account password and the local admin password. You'll need these values in the Key Vault for the ARM template deployment and the pipeline deployment coming up. Let's go to the host pool token. You'll need to add the host pool token. We can find this in the portal. This is the registration key that allows the Windows Virtual Desktop agent to connect to the host pool. We can find that in the Azure portal. We'll go to host pools. Select the host pool. Go to registration key. Copy that value. Paste the registration key in the host pool token field in the parameter file. We also need some settings from our Log Analytics workspace. Let's go to the workspace. Go to Agent Management. You'll need the workspace ID and one of the registration key for the parameter file. Let's go back to the parameter file. Be sure to update the host pool token with that registration key, as well as the workspace ID and the workspace key from your Log Analytics workspace. Before we move on to the pipeline, it's important to run a deployment manually and verify it finishes without errors. It's easier to troubleshoot here than in the pipeline. Let's change the number of VM instances to 1. We don't need any more than that. Save the file. Next, we're going to run the manual deployment. So we'll open up the terminal. You can use get AZ context to verify you're logged in. And we're going to run new -AZ resource group deployment. Give the deployment a name. Specify a resource group. This is the resource group of your current session host. Remember, we're adding new session hosts to an existing resource group. Then we're going to specify the template parameter file. Next, specify the template file. Make sure that all looks okay. Once ready, click Enter to deploy. Providing there's no errors, this should take a few minutes to finish. I'll pause here and come back once it's done. All right, that finished. Let's see if it shows up in the host pool. Let's go to our host pool and go to session host. I've got a mix here, but you can see the bottom one is the session host we just deployed. Good, so this was just a test. We can remove the session host. I'll remove it from the host pool first, and I'll come to my resource group. And I'll select the availability set and all of the resources belonging to that virtual machine. And we can just delete those. All right, let's go back to VS Code. At this point, we have a working template and parameter file. Let's go to the template parameter file. We're going to remove the security items before we push it to the repo. It's a bad practice to keep security items in clear text in a repo. Let's go up to the top. And first, we'll remove the host pool token. And I'm just going to copy this empty value because we're also going to remove the administrator account password. So we can remove everything between the administrator account password brackets. Formatting this properly is important with JSON, so make sure you don't remove too many brackets or not enough brackets. We're going to remove the VM administrator account password as well. Leave the VM custom image source ID. And last, we'll remove the value from the workspace key. Now we'll save our parameter file. And once they're saved, let's push the files up to DevOps. We'll commit the change. I've got a couple extra files in there. One of them will be available with the source files that I publish. The other one I just used for this video. And we'll do our initial commit. Once that's committed, we'll push. Now that that's committed, let's go to Azure DevOps. Here we are in DevOps. Before we get started, let's go to the parameter file and change the number of instances from 1 to 3, or however many session hosts you want to deploy. Click Edit and change the number of instances. And then commit. This project needs a service connection, so if you don't have one already, go into Project Settings, go to Service Connections, and create a service connection. Select Azure Resource Manager, and we'll leave it as automatic. Sign in if prompted. Select the subscription, and give it a name. SHBuild for this example. Click Save. You may get prompted along the way to enter in your credentials. Now our service connection has been created. From here, go to Pipeline, and then go to Library. Add a new variable group. Let's call this one Key Vault. Link the secrets from the Azure Key Vault. Under Azure Subscription, select the service connection, and then select the Key Vault name. This is the Key Vault with the secrets we'll use. Once you have that selected, click Authorize. And here again, you'll need to sign in. Let's add the variables for the local admin and the domain join account. And click OK. Click Save to finish. Your screen should look something like my screen. Now that we have that in place, let's create the pipeline. We're going to go to Repos. Here are the files we were working on in VS Code. We have our template file and our parameter file. From the repo, let's go Setup Build. Select a starter pipeline. The first thing to do is comment out the trigger. Control// will comment out a block of code. You can change this back once finished if needed. I just want to limit VM builds until I'm ready. Let's add trigger none, PR none next. After that, we need to add some variables. These variables will be available in the entire pipeline. They'll be used for PowerShell tasks to get items like the registration and the workspace key. We'll add these after the trigger. We have 4 variables: the host pool resource group, host pool name, log analytics workspace, and log analytics workspace resource group. Update these with the values for your environment before moving on. Next up, we'll add some steps. Remove everything under steps. And go to Show Assistant. Once in the Assistant, search for Key Vault. And select Azure Key Vault. The subscription will be the service connection. Key Vault is the Key Vault with our secrets. Leave the secrets as a wildcard so the pipeline can access all of them. Click Add to add the first step. For each one of these steps, we'll need to manually add the display name. We'll give this the name Get Key Vault Vars. Let's go to the last line. Next up, we'll use a PowerShell command to get the host pool registry key. Go to Assistant and search for PowerShell. Select our service connection for the subscription. We'll use an inline script. Paste in the code to get the registration key. I'll have this available with the rest of the code in the link below. It's located in a PS1 file. set to use the latest installed version, and click Add. Let's take a second to look at the code. First, it gets the token or registration key from the host pool. Depending on the environment, the host pool may already have a registration key available. The next block of code is an if statement that checks to see if the key is empty. If it is, that means that there's no key available. In that case, it'll create a key with a lifetime of 24 hours. Let's take a closer look at the variables because we have a couple different types. The first, $host pool reg key, is a PowerShell variable created and only available in this task. Once the task finishes, that variable's gone. Also notice for resource group and host pool name, we have parentheses around the variable name. This is a pipeline variable. The actual value is coming from the variables we set at the beginning. Those variables are available in the entire pipeline. We need the host pool reg key for an upcoming step. The last line of code creates a pipeline variable called host pool reg key with the value of the PowerShell variable, host pool reg key. Now we can call that host pool reg key the same way we call the host pool resource group and name. Keep in mind that order is important. We couldn't call the host pool reg key pipeline variable before it was created, unless we had a dependency statement, but let's just keep these in order for simplicity. Let's add a display name, get host pool reg key for this example. And let's go to the end, create a new line. Next, let's create a new PowerShell task to get the Log Analytics workspace key. Go to Show Assistant and search for PowerShell. Set it like the last one with the inline script and latest version. And then add the code to get the Log Analytics workspace key. We'll add that. Here, it again uses the pipeline variable to get the workspace key, and then it creates a new pipeline variable to use later. Let's give it the display name, get log analytics key. Next, we'll set the name prefix. Go to the next line, and again, another PowerShell task. Like before, create a new PowerShell task and paste in the inline code. Once it's entered, click Add. This builds a session host name prefix. The prefix will start with SH and then have a 10-digit date after that. All resources, including the availability set, will have this prefix as part of the name. This makes removing those resources easier later on. The date down to the minute is there, so it'll be unique between runs. Something to keep in mind, the prefix is 12 digits and a hyphen with a number will be appended to the end of that for the session host name. A session host name can't exceed 15 characters. So that means we're limited to creating up to 99 session hosts with this format. You can change this to fit your naming convention or leave it as is. We'll give it a display name, set sh prefix. Okay, let's stop here for a second and consider what we've done so far. Remember, we had the template and parameter file working with a manual deployment. After that, we removed references to the key vault and the domain join and local admin account. Then we removed the value for the host pool registration key and the log analytics workspace key. So far, we've created the key vault reference for the passwords in the pipeline. That's the local admin and the domain join account. That way, if we change the password in the key vault, the pipeline will use the most recent version of that from the key vault. After that, we used pipeline variables and PowerShell to get the host pool registration key and the log analytics workspace key. We also created a new host name prefix that will be unique to each run. This is important to identify session hosts if you're rotating out old ones and replacing them with new. Let's move on to the template deployment next. Go to the next line, and this time we'll search for ARM template deployment. Set to resource group and select the connection for the subscription. Select your subscription. Leave action to create or update resource group. Select the resource group for your session host. This should be the same as used for the manual deployment. And set the location. Again, this is the same as the manual deployment. Next, enter the name of the template. Case is important here, and I just assume everywhere else in the pipeline as well. Enter the name of the parameter file. Next is the override parameters. These will replace any parameters in the parameter file. We'll add it as one line without any line breaks. Once entered, click Add. We'll give it a display name, build session host for this example. Let's minimize tasks and take a look at this. Our override parameters will do just that. They override what's in the template file or the parameter file. So the host pool token, we pulled that value out. Now we're adding it back in as a pipeline variable, as well as the administrative account password. That's coming from the key vault. The VM administrator account password is coming from the key vault as well. We created a VM prefix based on the date, and then the workspace key is last. And that's the workspace key for log analytics. Now that we have all that, let's go to the next line. And there's one more task. This will enable drain mode on these new VMs. This step is optional. After we deploy the session host, we might want to log in and validate that they're working correctly before we make them available to everybody in the pool. This last step will put them in drain mode, so nobody will access them until you manually take them out of drain mode. Create a new PowerShell task. Inline again. We'll paste in the commands, set it to latest installed version, and click Add. Next, we'll give it a display name. And we'll call this Enable SH Drain Mode. That is it. That's the pipeline. Now the fun part. Let's save and run. We'll go to Save and Run, and save to commit, and then run the pipeline. Let's go to the job. And here we can see the output of each task. If all goes as planned, there'll be no red. This is going to take a while to finish. I'm going to pause here and come back once it's done. Good news, the job finished successfully. We can go to each task and see the output. If a task does fail, you can view the details to see what went wrong. Let's go to Windows Virtual Desktop and into the session host. I'll go to Host Pools, select my host pool, and go to Session Hosts. Here we have the 3 previous session hosts and the 3 new ones with drain mode enabled. And it looks like I also left drain mode on for the first 3 session hosts as well. Good thing this is a lab. You can now run any validation steps needed and then turn off drain mode to add them to production. After that, you could enable drain mode on the previous versions and remove them once all the users are logged off, making a smooth transition to the new session hosts. That is one of the ways to deploy session hosts with an Azure DevOps pipeline. That's how to deploy session hosts with an Azure DevOps pipeline and ARM templates. Don't forget to like and subscribe, and thank you for watching.